Getting started. Welcome to Sam's Teach Yourself C++ in 21 days. Today, you will get started on your way to becoming a proficient C++ programmer. Today, you will learn why C++ is a standard in software development, the steps to develop a C++ program, how to enter, compile, and link your first working C++ program. A brief history of C++. Computer languages have undergone dramatic evolution since the first electronic computers were built to assist in artillery trajectory calculations during World War II. Early on, programmers worked with the most primitive computer instructions, machine language. These instructions were represented by long strings of ones and zeros. Soon, assemblers were invented to map machine instructions to human-readable and manageable mnemonics, such as ADD and MOV. In time, higher-level languages evolved, such as BASIC and COBOL. These languages let people work with something approximating words and sentences, referred to as source code, such as let I equals 100. These instructions were then translated into machine language by interpreters and compilers. An interpreter translates and executes a program as it reads it, turning the program instructions, or source code, directly into actions. A compiler translates source code into an intermediary form. This step is called compile-ing, and it produces an object file. The compiler then invokes a linker, which combines the object file into an executable program. Because interpreters read the source code as it is written and execute the code on the spot, interpreters can be easier for the programmer to work with. Today, most interpreted programs are referred to as scripts, and the interpreter itself is often called a script engine. Some languages, such as Visual Basic 6, call the interpreter the runtime library. Other languages, such as the Visual Basic.NET and Java, have another component, referred to as a virtual machine, VM, or a runtime. The VM or runtime is also an interpreter. However, it is not a source code interpreter that translates human-readable language into computer-dependent machine code. Rather, it interprets and executes a compiled computer-independent virtual machine language, or intermediary language.
यहाँ तक तो समझ में आया कि इन्होंने क्या करा कि जो डिजिट्स इस्तेमाल कर रहे थे ज़ीरोज़ और वन, उसको फिर इन्होंने एक सिंबल्स के इक्वल कर दिया।
हाँ, मतलब बेसिक मोटो ये था कि मतलब जो हमारी असेंबली लैंग्वेज है जीरो वन, उसको पहले हैंडल करना मुश्किल होता था, इतना हर कोई उसको हैंडल नहीं कर सकता, तो इसलिए ऐसे कंपाइलर ऐसे सॉफ्टवेयर डिजाइन किया जिसके अंदर आप ह्यूमन लैंग्वेज को मशीन लैंग्वेज में कन्वर्ट कर दें और प्रोग्राम को एग्जीक्यूट करें।
विजुअल बेसिक हो गई और जावा जो है, इनके पास इंटरप्रेटर के अलावा एक और कंपोनेंट होता है जिसको रन टाइम कहते हैं।
Compilers introduce the extra steps of compiling the source code, which is readable by humans, into object code, which is readable by machines. This extra step might seem inconvenient, but compiled programs run very fast, because the time-consuming task of translating the source code into machine language has already been done once, at compile time. Because the translation is already done, it is not required when you execute the program. Another advantage of compiled languages, such as C++, is that you can distribute the executable program to people who don't have the compiler. With an interpreted language, you must have the interpreter to run the program. C++ is typically a compiled language, though there are some C++ interpreters. Like many compiled languages, C++ has a reputation for producing fast but powerful programs. In fact, for many years, the principal goal of computer programmers was to write short pieces of code that would execute quickly. Programs needed to be small because memory was expensive, and needed to be fast because processing power was also expensive. As computers have become smaller, cheaper, and faster, and as the cost of memory has fallen, these priorities have changed. Today, the cost of a programmer's time far outweighs the cost of most of the computers in use by businesses. Well-written, easy-to-maintain code is at a premium. Easy to maintain means that as requirements change for what the program needs to do, the program can be extended and enhanced without great expense. The word program is used in two ways, to describe individual instructions, or source code, created by the programmer, and to describe an entire piece of executable software. This distinction can cause enormous confusion, so this book tries to distinguish between the source code, on one hand, and the executable, on the other. Note: the need for solving problems. The problems programmers are asked to solve today are totally different from the problems they were solving 20 years ago. In the 1980s, programs were created to manage and process large amounts of raw data. The people writing the code and the people using the program were computer professionals. Today, computers are in use by far more people, and most know very little about how computers and programs really work. Computers are tools used by people who are more interested in solving their business problems than struggling with the computer. Ironically, as programs are made easier for this new audience to use, the programs themselves become far more sophisticated and complex. Gone are the days when users typed in cryptic commands at esoteric prompts, only to see a stream of raw data. Today's programs use sophisticated user-friendly interfaces involving multiple windows, menus, dialog boxes, and the myriad of metaphors with which we've all become familiar. With the development of the web, computers entered a new era of market penetration. More people are using computers than ever before, and their expectations are very high. The ease at which people can use the web has also increased the expectations. It is not uncommon for people to expect that programs take advantage of the web and what it has to offer. In the past few years, applications have expanded to different devices as well. No longer is a desktop PC the only serious target for applications. Rather, mobile phones, personal digital assistants, PDAs, tablet PCs, and other devices are valid targets for modern applications. In the few years since the first edition of this book, programmers have responded to the demands of users, and, thus, their programs have become larger and more complex. The need for programming techniques to help manage this complexity has become manifest. As programming requirements change, both languages and the techniques used for writ-ing programs evolve to help programmers manage complexity. Although the complete history is fascinating, this book only focuses briefly on the key part of this evolution, the transformation from procedural programming to object-oriented programming. Procedural, structured, and object-oriented programming. Until recently, computer programs were thought of as a series of procedures that acted upon data. A procedure, also called a function or a method, is a set of specific instructions executed one after the other. The data was quite separate from the procedures, and the trick in programming was to keep track of which functions called which other functions, and what data was changed. To make sense of this potentially confusing situation, structured programming was created. The principal idea behind structured programming is the idea of divide and conquer. A computer program can be thought of as consisting of a set of tasks. Any task that is too complex to be described simply is broken down into a set of smaller component tasks, until the tasks are sufficiently small and self-contained enough that they are each easily understood. As an example, computing the average salary of every employee of a company is a rather complex task. You can, however, break it down into the following subtasks. 1. Count how many employees you have. 2. Find out what each employee earns. 3. Total all the salaries. 4. Divide the total by the number of employees you have. Totaling the salaries can be broken down into the following steps. 1. Get each employee's record. 2. Access the salary. 3. Add the salary to the running total. 4. Get the next employee's record.
आगे फिर हमने यही करा कि जो पहले प्रोग्राम्स बनते थे पहले ज़माने में, उनका जो मकसद होता था वो सिर्फ खाली जो रॉ डेटा उसको इनपुट करना होता था. हमारे पास जो प्रोग्रामिंग होती थी वो ऑब्जेक्ट ओरिएंटेड नहीं होती थी.
उसके बाद ये होता था प्रोसीजरल होती थी. एक प्रोसीजर फॉलो करते थे, उसके बाद स्ट्रक्चरल हो गई और उसके बाद ऑब्जेक्ट.
देखो जो अपन बनाते हैं प्रोग्राम वो होता है सोर्स कोड, सही है. बाकी जो कंप्यूटर में जो अपना कंपाइलर होता है वो कन्वर्ट करता है दूसरे कोड में, वो होता है हमारा ऑब्जेक्ट कोड होता है वो. जो ऑब्जेक्ट कोड जो होता है वो इजीली अंडरस्टैंडेबल बाय कंप्यूटर होता है, सोर्स कोड का हार्डली अंडरस्टैंडेबल। ऑब्जेक्ट कोड जो होगा ना, ऑब्जेक्ट कोड जो होगा वो लो लेवल लैंग्वेज, वो सोर्स कोड हाई लेवल लैंग्वेज।
यानी सोर्स कोड जो होता है वो हमारी अंडरस्टैंडिंग के लिए होता है और ऑब्जेक्ट कोड मशीन की अंडरस्टैंडिंग के लिए होता है।
After your source code is compiled, an object file is produced. This file is often named with the extension .obj or .o. This is still not an executable program, however. To turn this into an executable program, you must run your linker. Creating an executable file with the linker. C++ programs are typically created by linking one or more object files, .obj or .o files, with one or more libraries. A library is a collection of linkable files that were supplied with your compiler, that you purchased separately, or that you created and compiled. All C++ compilers come with a library of useful functions and classes that you can include in your program. You'll learn more about functions and classes in great detail in the next few days. The steps to create an executable file are: 1. Create a source code file with a.cpp extension. 2. Compile the source code into an object file with the .obj or .o extension. 3. Link your object file with any needed libraries to produce an executable program. Do use a simple text editor to create your source code, or use the built-in editor that comes with your compiler. Do save your files with the .c, .cp.
अच्छा, ये डू और डोंट मैंने इस बुक की स्टार्टिंग में पढ़ा था। ये इस वजह से नहीं है ताकि हमें जो भी हम पढ़ रहे हैं ना उससे जो समरी बनती है, तो उस समरी के अंदर डू वो है जो हमें करने चाहिए और डोंट वो है जो नहीं करने चाहिए।
CP or .cpp extension. The .cpp extension is recommended. Do check your documentation for specifics about your compiler and link. If you do use a word processor, save the file as ASCII text. Don't use a .c extension if your compiler treats such files as C code instead of C++ code.
यानी हमें कंपाइलर के हिसाब से फाइल को सेव करना होगा।
The development cycle. If every program worked the first time you tried it, this would be the complete development cycle. Write the program, compile the source code, link the program, and run it. Unfortunately, almost every program, no matter how trivial, can and will have errors. Some errors cause the compile to fail, some cause the link to fail, and some show up only when you run the program. These are often called bugs. Whatever type of error you find, you must fix it, and that involves editing your source code, recompiling and relinking, and then rerunning the program. This cycle is represented in Figure 1.1, which diagrams the steps in the development cycle. Figure 1.1 The steps in the development of a C++ program. Start. Edit source code. Compile. Compile errors. Link. Link errors. Run program. Runtime errors. Hello.cpp, your first C++ program. Traditional programming books begin by writing the words "Hello World" to the screen, or a variation on that statement. This time-honored tradition is carried on here. Type the source code shown in listing 1.1 directly into your editor, exactly as shown, excluding the line numbering. After you are certain you have entered it correctly, save the file, compile it, link it, and run it. If everything was done correctly, it prints the words "Hello World" to your screen. Don't worry too much about how it works. This is really just to get you comfortable with the development cycle. Every aspect of this program is COV-aired over the next couple of days. For example, on line 1 of listing 1.1, you should enter hashtag include iostream. Caution. Listing 1.1 hello.cpp, the Hello World program. 1. Hashtag include iostream 2, 3, int main, 4, 5, std, coot hello world, \n, 6, return 0, 7. Be certain you enter this exactly as shown. Pay careful attention to the punctuation. The on line 5 is the redirection symbol, produced on most keyboards by holding the Shift key and pressing the comma key twice. Between the letters STD and COOD on line 5 are two colons, smiley face. Lines 5 and end with semicolon, winky face. Also check to ensure you are following your compiler directions properly. Most compile ERS link automatically, but check your documentation to see whether you need to provide a special option or execute a command to cause the link to occur. If you receive errors, look over your code carefully and determine how it is different from the preceding listing. If you see an error on line 1, such as cannot find file iostream, you might need to check your compiler documentation for directions on setting up your include path or environment variables. If you receive an error that there is no prototype for main, add the line int main just before line 3. This is one of those pesky compiler variations. In that case, you need to add this line before the beginning of the main function in every program in this book. Most compilers don't require this, but a few do. If yours does, your finished program needs to look like this. Hashtag include iostream int main. / most compilers don't need this line int main, std, coot hello world, \n, return 0. 18 day 1. It is difficult to read a program to yourself if you don't know how to pronounce the special characters and keywords. You read the first line #include, some say #include, others say #include, iostream. You read the fifth line std out hello world. Note: on a Windows system, try running hello.exe, or whatever the name of an executable is on your operating system. For instance, on a Unix system, you run hello, because executable programs do not have extensions in Unix. The program should write hello world directly to your screen. If so, congratulations! You've just entered, compiled, and run your first C++ program. It might not look like much, but almost every professional C++ programmer started out with this exact program. Some programmers using IDEs, such as Visual Studio or Borland C++ Builder, will find that running the program flashes up a window that promptly disappears with no chance to see what result the program produces. If this happens, add these lines to your source code just prior to the return statement. char response, std, cin response.
इसमें यही कहा है ना इसने कि अगर हम हमारे पास कंपाइलर कोई दूसरा हो तो हम ये इस्तेमाल करेंगे, करेक्टर रिस्पॉन्स।
मतलब उसमें मतलब कंपाइलर में बोल रहा है कि वो स्क्रीन चल रही नहीं हो, बस नहीं कर रहा हो, तो फिर आपको कोड लिखना पड़ेगा अपने। वही जाते बताया इसने कि विजुअल स्टूडियो इसमें आता है।
I also need to press the enter key. They ensure you have a chance to see the results of your test run. If you need to do this for hello.cpp, you will probably need to do it for most of the programs in this book. Getting started with your compiler. This book is not compiler specific.
उसमें ये होता है कि आईएसटी की फाइल है ना, इधर एच लगाना पड़ता है, जो को हेडर फाइल लगाना पड़ता है। लेकिन अब जो नए कंपाइलर है जैसे डेव अपना, मैं आईएसटी में एच लगाते थोड़ी हैं।
.h वो कह रहे हो ना?
हाँ हेडर फाइल बताना पड़ती है। ठीक है, ये लाइट पुराना है, 80 से भी पहले का है, तो सी तो इसमें बड़ा मतलब। लेकिन C++ में फिर नई लाइब्रेरी ऐड होती रहती हैं। अब हर कंपाइलर का अलग अलग लाइब्रेरी होती है। अब डेव जो होगा, अब अपन वो करते हैं ना कोड ब्लॉक के अंदर अपनी आईओस्ट्रीम की मसला करती थी बार बार, तो या तो उसका ये मतलब हो सकता था कि आप उसके साथ एच यूज करना था, तो दूसरा ये मतलब हो सकता था कि वो कंपाइलर के अंदर वो जो लाइब्रेरी थी शायद वो इंस्टॉल ही नहीं हो। दो मसले होते।
This means that the programs in this book should work with any ANSI-compliant C++ compiler on any platform, Windows, Macintosh, Unix, Linux, and so on. That said, the vast majority of programmers are working in the Windows environment, and the vast majority of professional programmers use the Microsoft compilers. The details of compiling and linking with every possible compiler is too much to show here. However, we can show you how to get started with Microsoft Visual C++ 6, and that ought to be similar enough to whatever compiler you are using to be a good head start. Compilers differ, however, so be certain to check your documentation. Building the Hello World project. To create and test the Hello World program, follow these steps. 1. Start the compiler. 2. Choose File, New from the menus. 3. Choose Win32 console application, and enter a project name, such as Hello, and click OK. 4. Choose an empty project from the menu of choices and click Finish. A dialog box is displayed with new project information. OK. You are taken back to the main editor window. 6. Choose File, New from the menus. 7. Choose C++ source file, and give it a name, such as Hello. You enter this name into the file name text box. 8. Click OK. You are taken back to the main editor window. 9. Enter the code as indicated previously. 10. Choose Build hello.exe from the menus. 11. Check that you have no build errors. You can find this information near the bottom of the editor. 12. Run the program by pressing Ctrl plus F5, or by selecting Build, execute Hello from the menus. 13. Press the spacebar to end the program. 20. Day 1. FAQ: I can run the program, but it flashes by so quickly I can't read it. What is wrong? Answer: check your compiler documentation. There ought to be a way to cause your program to pause after execution. With the Microsoft compilers, the trick is to use Ctrl plus F5. With any compiler, you can also add the following lines immediately before the return statement, that is, between lines 5 and 6 in listing 1.1 char response, std, cin response. This causes the program to pause, waiting for you to enter a value. To end the program, type any letter or number, for example, 1, and then press enter, if necessary. The meaning of std, cin and std, cout will be discussed in coming days. For now, just use it as if it were a magical incantation. Compile errors. Compile time errors can occur for a number of reasons. Usually, they are a result of a typo or other inadvertent might not only tell you what you did wrong, they point you to the exact place in your code where you made the mistake. The great ones even suggest a remedy. You can see this by intentionally putting an error into your program. If hello.cpp ran smoothly, edit it now, and remove the closing brace on line 7 of listing 1.1. Your program now looks like listing 1.2. 1. Listing 1.2 demonstration of compiler error. 1. Hashtag include iostream 2, 3, int main, 4, 5, std, cout hello world, \n, 6, return 0. Recompile your program, and you should see an error that looks similar to the following. Hello.cpp, 7, fatal error C1004, unexpected end of file found. Line number of the problem. The problem is, although I admit it is somewhat cryptic. In this case, the compiler is telling you that it ran out of source lines, and hit the end of the source file without finding the closing brace. Sometimes, the error messages just get you to the general vicinity of the problem. If a compiler could perfectly identify every problem, it would fix the code itself. Today, you learned how to enter, compile, link, and run your first C++ program, and what the normal development cycle is. You also learned a little of what object-oriented programming is all about. You will return to these topics during the next 3 weeks. Q&A. Q. What is the difference between a text editor and a word processor? A text editor produces files with plain text in them. No formatting commands or other special symbols are used that might be required by a particular word processor. Simple text editors do not have automatic word wrap, bold print, italic, and so forth.
Don't forget to click subscribe to get more updates.